today's session, I'll be the moderator. So we will start for the Muslim with Al-Fatiha first. All right. So first of all, thank you for all the students for joining this webinar. Actually, this webinar is very useful to everyone who is in the final year because you need to know this knowledge in order for you to prepare for your final year project, okay, for the assessment part. So it's my pleasure today to introduce our speaker for this performance evaluation session, which is who is Associate Professor Dr. Shahnur Banun Sahran from our faculty, okay, FTSM. So Dr. Shah is the head of Medical Computing Lab, MC, under the Center of Artificial Intelligence Technology, CAIT. So her expertise is many, but then I'll just read a few here, which is image processing, simulation and modeling, data analytics, programming language technology. So we are really honored, Doctor, to have you today to share the knowledge and experience with our students. So before we begin, I would like to inform all of the students, during the session, feel free to write your questions in the chat box, yeah? So I will help to read the questions during the Q&A session later. So make sure you have at least one question from each of you because we are not that many because we are having some parallel session. Another one is for user acceptance test and which is conducted by Dr. Bahari and also together with the speaker, Professor Madhya, Dr. Fazida. And we have another session with me today with Dr. Shah. So you are not so many people. I can see only 58, around 57 of you are here. So I believe you have a few questions to ask. And please utilize this platform to clear up whatever in your mind, okay? So it will be easy and beneficial for your preparation for the final year project reports, all right? So without further delay, I would like to invite Dr. Shah. Dr. Shah, the session is yours. Start from now, okay?
Okay. Okay, thank you, Dr. Faz, for the introduction. Okay, Assalamualaikum and good afternoon, everyone. So I'm going to give some guidelines, okay, on about project on AI, using AI, okay. So I will start with the topic actually I want to present here is about the life cycle of an AI project. Next slide, please, Wani.
Saya dah buka yang slide kedua.
Tidak gerak lah pula.
Tak nampak ya, Prof? Doktor.
Saya tak nampak pula. Okay, dilambatlah keluar. Okay. So, okay, table of contents. Yeah. So in this presentation, I will divide the presentation into 3 stages. Stage 1 is about planning and collecting data. Stage 2 is about training your machine learning model. Okay, so when I said machine learning, it will cover also deep learning lah. Okay. Stage 3 is about the deployment of the model. Okay, next slide. Okay, basically this is a framework, yeah, of of AI project. Okay, the first column is about planning and collection. So this planning and collection involve few steps here. One is the problem definition, and then we have project motivation, collecting big data, or actually it's not about collecting big data, it's about collecting the right data. Okay, and then data improvement. Also, the last one might be data annotation. Okay, after we finish or complete our planning and data collection, we go to the next step, which is design and training. So basically, under design and training, we have model building, where you start to develop your model, machine learning model. And then we go for evaluation. After that, we go for refinement or fine tuning. Yeah, and then we go for training. training, validation, and testing. And after that, you will get your live model. Okay, so then the last step will be the deployment of the model. Okay, deployment of model. Basically, some of the students, they don't go until deployment. Yeah, they just until coming out with the live model, with the model offline model, and then they just test with the benchmark data set. But uh, say for, I mean, a good project should have a deployment lah. Okay, we will discuss about this later. Yeah, so deployment can be you launch or maintenance or edge device, meaning that coming up with the system or the output, you test it with the real world application. Yeah, that's what I mean by deployment here. Okay, then next slide, please. Okay, so the most important part of AI project is planning and collecting. Yeah, why? Okay, first, because this stage involves the planning and motivational aspect of your project. So meaning that you will need to calculate the potential profitability of the future machine learning model and work out the process of its adoption. The second one, it's important to start strong if you want your AI project to be successful. I'm sure you already heard about this garbage in, garbage out. Okay, so this means that if your data is not good, okay, meaning that the output also will be not perfect. Yeah. So meaning that collecting right data is very important. It's not just about collecting big data, but the most important part is to collect the right data. Yeah. Okay, next. Okay, problem definition. Uh, okay, problem definition is very important. Yeah. So how can you come up with a good problem definition? It depends. Some project, the problem comes from the domain, okay, or from the industry, or might be from the agency. Eh? So it depends which agency are you working with. For example, if you are working with a hospital, so your data and your problem come from the hospital. So it is a good opportunity and a good experience for students to work with outside agency or industry to come up with the real world problem. So for my student, normally I will ask them to work with outside, to work with industry or agency to get what is your problem, okay, that we can help to solve them using AI. Okay, why? Because when we work with real world data, we can see what are the gap, what are the things that um, machine learning can offer. Yeah? And there are so many things that you can learn, not only just about the data, but communication or collaboration with industry and also agency. So, and then another way for you to good to have a good problem definition is to find a good journal. Okay, try to find a good journal so that you are able to find out a good problem statement. Okay, so problem definition is think about the motivation for your future cognitive model. Is there a problem it can solve, or is there a lack of efficiency? So, or perhaps a process it can automate so your employees can focus on more value adding tasks. And then, do you need a chatbot capable of mimicking emotion or a facial recognition model or maybe an attendance monitoring system? Okay, so look for the relevant real life use cases that your AI project will address. Collect complaints from the users and observations from the employees. So that's why if you work with industries or agencies, they will give you we say their problems, yeah? And then we try to solve their problem. So in that way, we are working with the real world application. Okay, so the problem will come from them, the solution will come from us, right? Next. Okay, project motivation. Okay, you can use reference from good journals, a website, or any types of publications. For example, if you are working on time series data, then find a few journals related to time series with machine learning approach. Okay, try to find a reference 5 years back only, yeah. Okay, and then find a good journal lah, high ranking journal. Okay, in case you don't have, sometimes if students are doing we say new approach, it's quite difficult to find a journal. Then you can try to find a good conference, yeah, as a reference. If you are working on medical images, then find a few journals related to medical images with machine learning approach or any deep learning approach lah. Or if you want to work with reinforcement learning, try to find journals that works on reinforcement learning. Okay, the number of journals that enough for you to make a reference, I think 5 to 10 is enough for undergraduate. Yeah, but if you want to read more, doesn't matter. It's good lah if you can read more. But for me, for undergraduate, 5 to 10 is enough. Yeah. Okay, next. Okay, data collection. Okay, understanding what data your AI project requires is paramount or important. This is where the garbage in, garbage out principle plays out. So if the data you collect is low quality or insufficient, so your machine learning model will not work most of the time. Okay, but nowadays when we talk about this number of data, especially for those who do research on medical, okay, and any other domain. Sometimes it's very difficult to get enough data set. But today we have approaches that can help you to work with this type of problem, such as data augmentation. So your focus might be for the machine learning, you can focus on the data augmentation. So for today, I think there are so many, we say, approaches, or there are so many problems that you can highlight. If you don't have enough data set, you still can work with the data set, but you can use data augmentation approaches. When you use data augmentation approaches, I believe there are other issues that you need to solve also when you use data augmentation. Yeah. So I don't think these days data will be big issues lah. Okay, because there are many solutions that you can use. Yeah. So the first one, when we talk about data, is about big. The more, the better. Yes, the more you have the data set, the sample size, the bigger the bigger sample size that you have. In theory, it will give you better performance. Yeah, but make sure it is the right data, not only big but also right data. Yeah. And then let's say you have a very big data. First step you should do is that you should try with small portion of the data first, just to make sure that this data can work or how it works with your algorithm. Yeah, then after that only you try to implement the whole data set. Okay, try with small data set first, then go big. Right. The second one is relevant. It matches the problem. Make sure the data that you can answer the questions that you want to solve. Yeah? And then the third one is high quality, meaning that credible, reliable, real, and well structured. Do data quality report and discuss with experts. So if your project involved with industry or agency, it is very good if you make discussion with the expert or with the industries. Yeah? From there, you make a network, you make collaboration, and you understand that in the real life, there are so many processes that sometimes you never heard before, and also sometimes you never know that that small thing is very important for you to take care before you implement any machine learning model. Yeah. So where to get data? So basically, we can say that we have internal sources and also external sources. Yeah. What do we mean by internal sources is that the data that exists and is stored inside your organization. Okay, for example, our faculty, our hospital, yeah. And then external sources, we can say one is primary data and the other one is secondary data. So what is primary data? Basically, primary data is the data that you do your own collection, what we call self-collected data. Secondary data is periodical, such as journal, newspaper, government, publication, reports. That one already published. That is the one that normally we say try to find benchmark data set. So when you do a project, normally we will ask you to find benchmark data set. Why? Because you need to have a baseline, yeah, to make comparison for your findings. Okay, self-collected data, it's very good to do self-collected data, but it's very challenging because it will involve a lot of times. But basically, you will learn a lot of experience and process. Yeah. And self-collected data, basically, you need to verify the data. Okay, who can verify the data? Normally, the one, let's say we are working with industry, so the expert from industry will verify the data. If you are working with hospital, might be the medical doctor will verify the data that you have collected. Yeah. Okay, next slide. Okay, data improvement. Okay, okay, the data that you get from maybe from internet or self-collected data, sometimes they are noisy data. Yeah? So machine learning process steps in data preprocessing is how you can improve your data. So the first step basically is to import the libraries, import the data set, check out the missing values, see the categorical values, do the quality report. Yeah? And then step 6, should be step 6. You split the data into training, validation, and testing. Okay. In theory or in a normal situation, we can partition our data when we want to use AI into 3 partitions: training, validation, and testing. However, if your data set are not big enough, so you can just divide the data into into 2 portions, which is training and testing. Okay. If your data set is big enough, then it's good if you can divide them into 3, or else you can just divide them into training and testing. Okay, don't worry about that. As long as you divide them into 3 or 2 is enough already. And then when you split the data, splitting data is one of the methods that you can use in machine learning. Actually, there are other methods that you can use instead of just splitting. You can use cross-validation. Yeah, you can use cross-validation by using K4 if your sample data is small. This cross-validation will help you to balance the data of training and testing. And also this step is very important, training, validation, and testing. Okay. Most of the students, they are not alert that your model that you got for testing, you are not allowed to modify the model. Okay. So in machine learning, when you already divide your data into training, validation, and testing, after you train your data, you will get a train model. Okay. What is a train model? Train model is a model with its configuration. What is configuration in machine learning? Configuration is the parameters that you use for that model. For example, let's say you use artificial neural network. Okay, so after training, you need to mention what is the configuration that you use for that model. So example, the configuration consists of the number of layers, the number of neurons, the value of learning rate, um, and also might be the number of epochs. So you need to mention the parameter in your report, in your project. You need to mention when you write down, when you do documentation, you need to write down the configuration of your model. Yeah. And then validation. Okay. During training and validation, you are allowed to fine tune the parameters. Okay. But then for testing, when you use dataset for testing, you are not allowed to modify the parameter in the testing model to get best result. No, that one is wrong. Okay, completely wrong. Yeah, some students they did like that. Okay, they do modification or fine tuning during the testing. Testing is for you to test unseen data, meaning that new data set coming, you are going to test. So that's why you are not allowed to modify any parameters from the model during the testing set. Okay, remember that one. So you are only allowed to fine tuning during training and validation. Okay. And then step 6 is feature scaling, such as min, max, normalization, and standardization. Okay, so you can see the two boxes here. This is one of the example. Okay, this one is using min, max for this one, and then the other one is normalization, standardization. Okay, this one is standardization, this one is normalization. Okay. So these techniques actually rescale feature or observation value with distribution values between 0 and 1. Yeah? So this normalization and standardization is very effective technique, um, and it's very important. Okay, so why we need feature scaling? Okay, if an algorithm is not using feature scaling method, then it can consider the value. Okay, this is an example why it's important. 3,000 meter to be greater than 5 kilometer. Okay, but that's actually not true. And in this case, the algorithm will give wrong predictions. Okay, when you do your data set, you have the number of samples by the row, and you have the attributes or variables or features by the column. Okay, so some data sets, okay, the variables is in the unit is in meter. Some variables, the unit is in kilometer. Okay, so kilometer and meter, they are big different. Yeah, so in order for you to give, we say, a fair calculation, so you need to scale the variables. Yeah, the variables, so that the value of the variables will be between 0 and 1 to get the correct predictions. Or else, if you just maintain 3,000 meter and 5 kilometer in the same column, then your algorithm will give wrong predictions. Okay, and then this is also example lah, 3 features that say age, salary, type of apartment. So let's say consider a range of 10 to 60 for age, and then 1,200 to 40,000 for salary, and then 5 to 5 for type of flat. So it can apartment, sorry. It can be seen that salary feature will dominate all other features. Why? Because the value here is 1,200 until 40,000, while for age is only 10 to 60, and for type of flat is 1 to 5. So the value are different. So you cannot use, you cannot just proceed with this type of values. You need to do rescaling. Can use normalization or standardization. That is the purpose of feature scaling. And I believe that data improvement take almost 70% to 80% of your time in AI project, data collection. It consume a lot of time. Okay, next slide, please. Okay, this is about generalities about algorithms regarding the scaling of the data. Okay, some algorithm, it is compulsory to do feature scaling. Some of them is not compulsory. However, if you do feature scaling, sometimes it gives you faster result, sometimes it might take a longer result. Okay, let's say for example supervised algorithm, decision tree, scaling needed? No, because you know that the concept of tree is like, okay, let's say age less than 30, higher than 30. So you don't need actually scaling there. Okay, scaling is not compulsory. Random forest, you don't need scaling. Naive Bayes, no. Linear regression, no, but sometimes very helpful. Okay, SVM, yes, you need scaling. Yeah. Neural network, yes, you need scaling. So for unsupervised algorithms, k-means, yes, you need scaling. Association rule, yes, you need scaling. Yeah. So distance-based models such as SVM, KNN, k-means, and RVF kernel scaling is crucial. Why? Because they use the distance, measurement of distance. Okay. Gradient-based such as ANN scaling improves training speed. Okay, so basically this is, I mean, some guideline for you whether you need to do scaling or no. Yeah. So if scaling is not needed, it means you should not see changes between the results you obtain with or without scaling. Okay. So if it says yes, probably it means that scaling is useful as features should have the same order or magnitude for the algorithm to work properly. However, it does not mean that performance will increase. Yeah, sometimes it's just about the speed. Okay, next slide. Okay, this is about data annotation. So the process of labeling the data available in various formats, like text, video, or images. For supervised machine learning, label data sets are required so that machine can easily and clearly understand the input patterns. So for those who works on images, uh, uh, most probably in medical domain, uh, the expert will do the annotation. Okay, so let's say you are working on breast cancer data set. So the expert will annotate which part of the tissue that is labeled that is labeled as cancer or non-cancer. So there, I mean, when you work with the expert, you need to know that sometimes they are very busy. So that's why if you work with expert or industry, it might take a longer time for you to do the data collection, because we need data verification or validation and annotation from the expert. But it will give you good experience. Eh? Okay, next slide. So we finish with planning and collection. Okay, so the next step will be, next slide. Yeah. Okay, design and training. So there are several models that you can choose according to the objective that you might have. You will use algorithms of classification, forecasting, or clustering. Yeah. So basically for machine learning, we have classification, forecasting or prediction, and also clustering. Yeah. So model can be logic regression, can be applied to price prediction, fully connected networks for classification. So you need to know this model, basically what is the task that you want them to do. Okay, is it voice recognition or fraud detection, or is it segmentation? Okay, so this is about the design and training. Yeah. Next slide, please. So the design and training, okay, if you look at the machine learning process, okay, um, your raw data, okay, apply pre-processing, okay, so data, then you will get, okay, to apply pre-processing, you basically normally you use modules, data processing modules, okay, so and then you prepare the data, iterate until data is ready. Okay, so meaning that this one involve the data cleaning, missing data, imputation, all will be here. Okay, and then next, apply the learning algorithm to the data. So here where you choose your machine learning algorithm. okay, the potential of the algorithm. So, and then you do the training, validation, this one, model building, this one, it involves this part, okay, the evaluation, refinement training, and then at the end, you will have the candidate model, okay, and then after that, the deploy chosen model, and then chosen model, you go for applications. Okay, so this is a machine learning process. I believe all of you will go through this process. Okay, next. Okay, refinement or parameter tuning. If you look at these two figures, the one on the left side is on the mathematical part lah. Okay, basically the one that we want is in the middle, appropriate fitting. Okay, we don't prefer the underfitting and overfitting lah, of course. Yeah. So underfitting is where you don't sometimes happen because you don't have enough data set. Yeah. So you cannot do a proper we say classification. For overfitting, sometimes normally it happens when your algorithm is too perfect. Yeah. Why is it too perfect? Because you are trying to get perfect accuracy, might be. Yeah. So what happened is that the algorithm cannot be generalized when you use new data set. So, and this is what happened. Yeah. When the algorithm is too perfect, the classification will look like this. Not a single misclassification happened here. But we don't want this one. This one is too good to be true. So what we want is the model that appropriate fitting only. Yeah. So, okay, next slide. Okay, this is how we we say looking at the accuracy lah. Okay, how we want to identify whether it's overfitting, underfitting, or appropriate fitting. Okay, for example, let's say your training is 98%, validation is 80%, and testing is 78%. Okay, you can see uh, the testing. You can see that the value here is not stable. And if you look at underfitting also, the training, starting from training also is not good. Yeah? And then validation also not good, testing also not good. So this one is underfitting. But the one that we are looking for is the one that the training, the validation is testing, the value of the accuracy is very, it's close lah. It's close to each other. Yeah. Let's say, for example, training 90%, validation 88%, testing 87%. This one is, we say, is appropriate fitting. We don't want that training is too good, 98, but then for testing is very bad, 78. It means that it cannot generalize for new data. Yeah. Okay. Next slide. Okay, evaluation. So evaluation.
Doctor, sorry, I need to interrupt for a moment
Okay.
just
Yes.
to let the students know the chat box is not available currently. So that try to use the Q&A. If you can see at the screen part at the top, you can see the Q&A and the chat sign. So use that medium to come up with the questions. Yeah. So if you don't see anything in the chat, you cannot go into the chat. It's okay. So use the medium of Q&A there on the top of your screen. Okay, you can see Q&A, so you can use that medium to write on your questions. All right. Thank you. Sorry, doctor. You may proceed.
Okay. 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 Next, the most important part is evaluation. So how are you going to evaluate the performance of your AI model? Yeah. So there are different types of evaluation metrics available. Okay. So if you are doing classification, the normal evaluation matrices that we use is accuracy, or logarithmic loss, confusion matrix, area under curve, F1 score, precision, and recall. Let's say your data is not balanced. Uh, uh, F1 score is much appropriate to be used lah, instead of just accuracy. You need to use also F1. Okay. When sometimes when you want to make decision which model that you want to use for your classification, if you just use accuracy, it means that you are using single decision matrix, single decision making matrix. But sometimes you can also combine the decision making evaluation matrix, such as accuracy and F1 and precision and recall. So that one is what we call multi-criteria decision making. You can also do that. Okay. For further discussion, you can discuss with your supervisor lah, trying to find a paper. Okay, it's good. For students to go beyond, not just look at the accuracy, but also look at multi-criteria decision making. Yeah. And then we go for clustering. Clustering is not like classification because the data is not labeled. So the way of you evaluating it is not the same as classification. Yeah. So if you are using images, then you can compare the prediction with the ground truth. But if you don't have a ground truth, then you can use other methods. Yes lah. Okay, for example, number one, Silhouette score, Davis Baldwin index, and then you can use adjusted RAND index, normalized mature information, conviction matrix plus accuracy when labels are available. Okay, can treat clusters as classes. This one is a special case, but in cluster, it can be classes also. It depends on how, the objective of your project. Yeah. And then forecasting or prediction, the evaluation matrices can be, it must be based on error. So one of it is mean square error or mean absolute error. Okay. So different tasks of machine learning, you need to use different evaluation matrices. So you have classification, clustering, and forecasting. And the other one is the reinforcement learning. That one is another way lah. That one is based on feedback. Yeah. Next slide. Okay, classification accuracy is actually what is about the number of correct predictions divided by total number of prediction made. Okay, so that is classification accuracy lah. For example, consider that there are 98% sample of class A and 2% sample of class B in our training set. So then our model can easily get 98% training accuracy by simply predicting every training sample belonging to class A. Okay. Okay, next slide. Okay, this is confusion matrix. Confusion matrix is very important because there are a lot of things that information that you can get from here. Yeah. So so let's assume we have a binary classification problem. So we have some sample belonging to two classes, yes or no. So also we have our own classifier, which predicts a class for a given input sample. So on testing our model on 165 samples, we get the following result. So what you need to know is that how to read this confusion matrix. Okay, if you look at this confusion matrix, two columns is for predicted and the other two columns or row is for actual. Yeah. So for both of these type, we have yes or no. Predicted no, predicted yes, actual no, and actual yes. Yeah. So for actual no and predicted no, okay. Can you go to the next slide? Okay. This is the important part. Yeah? Based on that conversion matrix, you should be able to know what is true positive, true negative, false positive, and false negative. Yeah. The accuracy that you calculated just now is true positive plus false negative and divide by total number of samples. Can you go back to the previous slide? Okay. So the true positive is actually about yes and yes, meaning that the actual is yes and the predicted is also yes. So this here is what we call true positive. So you need to know which of these cell is for which definition, true positive, true negative, or false positive, or false negative. Okay, next slide. Okay, so make sure you know all these important terms, TP, TN, FP, and FN. Okay. Okay, next slide. And then we have other evaluation metrics such as area under curve. This is about to interpret the true positive rate, which is sensitivity, and also false positive rate, which is specificity. These two components, sensitivity and specificity, or precision and recall, they are very important. We say very important measurement for medical domain. Okay, because they are about life or death for medical domain. So not only the accuracy, but for in medical domain, they want to see the value of sensitivity and also specificity. So for those who work in a in medical domain, for example, when you do your output, make sure you have the accuracy, sensitivity, and specificity. And one more thing, when you run your experiment, let's say for your accuracy, make sure you run your experiment not less than 5 runs. What do I mean by runs is that not epochs. Runs mean one network, the whole network you run, you get one result. Okay. And then refresh and then you rerun another time, you get another result. Okay. So let's say you run for 5 times. So I believe that each time that you run, you will get slightly different answer for accuracy. So this difference, you will calculate the standard deviation. So when you put your results, okay, in a table or whatever presentation, you put the result with plus minus standard deviation. Okay, so that is how actually you should demonstrate your output. And not only the accuracy, but we will see the standard deviation also. Yeah. Okay, next slide. Okay, this is another one, evaluation metric, F1 score. You can read later. Okay, just using a formula. And this is important when your data is unbalanced data. Yeah, okay. Okay, this is precision and recall. Okay, you can just read. Yeah. Based on the confusion matrix. Yeah. So, okay, next slide. Okay, this is just an example of how to use, how to, we say, interpret from the confusion matrix. Okay, so from this confusion matrix, you can calculate the accuracy, the misclassification rate, the true positive rate, the false positive, true negative precision, and prevalence. Okay, so that's why I said you need to understand this confusion matrix. Okay. Okay, next. Okay, so we finish with design and training. So the last phase will be, next slide, deployment. Okay, so as I mentioned earlier, this is the machine learning process. So now you are at the end. Okay, you already choose the model. Okay, and then you want to apply to your, let's say you have a domain, let's say medical domain. So you apply the domain, you come up with, I'm sure at the end of undergraduate, you are going to come with a software, right? So for AI student, I believe, I mean, the software you need also to um, do proper software requirements lah. Okay, what the user need, user requirement, okay, process requirement, that one you need to define very well. And then also it's very good if you can ask the expert or the industry to validate or verify your system. Ask them to do some testing on your system, and you can have like say a very simple survey form just to get feedback from the industry or the expert about your system. Yeah. Okay. And then next. Okay. This is about the model selection. Like I mentioned just now, let's say you have few models. Okay. Um, let's say as I mentioned, you can only do modification or fine tuning in the training and validation process only. So let's say for training, model 1, you got 100%. Model 2, 100% also. Model 3 also 100%. So which one to choose? If in this case, you can choose any model, okay, because all of them give you 100%. So how to choose? You can choose any model based on your preference. Let's say your preference is that you want algorithm or machine learning, which is very simple. It's easy to understand. Okay. For example, if you're talking about financial industry, based on my experience, they prefer to use logistic regression. Why? Because they said logistic regression is very simple and easy to understand. Uh, and also the performance of logistic regression is not bad compared to other complex machine learning model. So, so that's why I said you can choose any other model based on your preference. If the performance uh, um, slightly difference lah. Okay, in this case, all give the same output. Then you can choose any based on your preference. Yeah. And then for the model performance evaluation, you look at the testing result. Okay, this is for the model selection. And then for the model performance evaluation, then you look at the testing result. Which one gives you the best performance, right? Next slide. Okay, the other important part is significant test. Okay. Um, let's say in your project you use 3 different models, machine learning model, and you find out that model 1, 2, and 3, they have slightly different in terms of the accuracy. For example, model 1, the accuracy is 97%. Model 2, the accuracy is 95%. Model 3 is 94%. So if you look at the value, there are different. Okay, there are some difference, but the difference might be not significant. What does it mean by significant? It means that if you use uh, any of this algorithm, it will give you the same, we say, the same uh, level of performance. Okay, so that one is meaning that it's not, I mean, the difference is not significant. When the difference is significant, it means that when you try to implement them, they will give you a different level of performance. Yeah. So in order for you to you say to confirm that there are really difference in terms of the performance, you need to use significant tests. Okay. So there are very significant tests you can use. If you're talking about only using 2 method, okay, let's say only method 1, let's say SVM and ANN, then you can use t-test. If you're talking about using more than 2, you can use ANOVA. So that one you have to read lah to find which significant test is more suitable for your data set. Yeah. Okay. One of my students last time, final year project, in the final year project, she did not do significant test, but then during his intern, he used machine learning also. So during the presentation, one of the manager asked the student, how do you know that, the 2 models are different in terms of the performance? Okay, so that's why I said significant test is very important. Okay, so because why I know, because the student came to me lah, doctor, how I want to answer this question. Yeah? So actually, it's about significant test. So it's good practice. Um, in your final year project, you do significant test just to make sure that the final answer that you get really make difference from the of the model. Yeah. Okay. Okay. Next slide. Okay. Finish. Habis. Any questions?
All right. So I cannot see any question in the Q&A platform here.
Yeah.
There is no questions. So are you guys really understand whatever Dr. Shah has been sharing to you so far? Ah, yes, okay. Some of you respond just using the thumbnails, yeah? All right. So if that's the case, perhaps I have some general question for you, Doctor. Okay, so
Okay.
just to enlighten the student if they have the same concern. Okay. All right. The first question should be very generalized. What are the biggest challenge that you think students are facing in this AI, especially final year projects?
Okay, I think based on my experience lah, most of the challenging part for AI project is one is about the data itself. Yeah, because student need to search for data, and then they after searching for the data, then they need to see whether the data is appropriate or not for their objective. Okay, and that one is basically if they try to find from internet, that one is what we call benchmark data. Okay, and then after that they need to do pre-processing. Okay, sometimes it just involve missing data, sometimes there are a lot of noisy data, so they need to do pre-processing, cleaning, and other models that they need to use to come up with a good data set. Yeah, so that one already take about 60 to 70% of their time. So that is the most challenging part lah. Okay, that one is if they are using secondary data. If they are using self-collected data, that one is another story lah. It's another challenging part also because they need to verify, okay, with the expert. Okay, but they will learn a lot of process and they will have a good experience on that lah. Yeah.
Okay. Okay. So, if I'm not mistaken, just now you have
And
shared in the slide regarding on the project life cycle, right?
yeah.
So, how do the students can improvise the AI project life cycle?
Okay. If you look at the project life cycle, that one is actually a quite old life cycle. Yeah. Because nowadays, most of the industry or agency, they are not just looking for AI solution, but they are looking for something that can be explainable or interpretability. Yeah, so that's why nowadays we have students who are using sharp analysis. Okay, so that at the end they can interpret or explain the output or the predictions. So that our industry or our expert they understand, especially in the medical domain, the doctors can know what actually happened behind the AI or the algorithm. Yeah, so that is I think one of the uh, things that student can improve lah in the life cycle. Explainability, interpretability, data augmentation, that one part of the solution lah. Yeah.
The student, don't you have any other questions? Are you serious? I believe you already understand better by now. So hopefully you can speed up your FYP submission. Yeah. If you got
Mm.
any complaints from your supervisor, then it's just not worth it to have this kind of medium for you, right? So better you use this utilize this platform for you to ask question. I give you some time here, while I'm just going to ask another maybe one or two questions to fill up the time. Okay, Doctor, another question that
Mm.
perhaps useful for the students as well. What would happen if the deployment stage is ignored in this whole cycle of develop FYP for the students especially?
Okay. Uh, Deployment, I think is not compulsory, but if you can deploy, you will get feedback for your system lah. Whatever you have developed, you can get feedback, and then you can know, I mean, the gap or the any leak of your system, okay, or your data, okay. It's not compulsory, but I think if students are able to, I mean, to manage their time, at the end they can do a deployment and they can get a good output. Yeah. Okay.
Okay.
Uh,
So,
Actually, for me, like if I evaluate student, if they can deploy the system and get some feedback, of course, I will give A lah. Most probably,
mm,
that one can get A.
so it's an added
Because
value
some
there, is
students
it?
they only want to do very simple project, and yet they want to get A. So you see, so A is for those who are really committed to do their project lah. So that's why if you can deploy and then you have good feedback, for sure you will get A lah. I mean, that's what
So
I mean
it's a
based on my
value added
experience.
and their experience, good for their
Yes,
experience as well, right?
yes.
Mm. Okay, so a part of that, which stage of the AI life cycle is usually most time consuming for the student to accomplish within this
Like I
time?
mentioned here in my presentation just now, the planning and collecting data. That one is the most part. Data mining. Say data mining, collecting data. That one will take about 60 to 70% of your time.
So at the beginning, there will be the
Yes.
challenge. Okay, all right. Okay, once again, this is the third time I'm calling for questions. Anyone wanted to ask question, you may switch on the mic as well. If you don't want to write on the chat box, you can always raise up your hand or switch on your mic to interrupt us here to ask question. Anything? Anyone? No one. I can see the name of Adam Haris. It's quite famous name. I don't know if the same person or not. Do you have any questions?
I'm good. I'm good.
You are good. All right. Hopefully your supervisor will be happy with you. Okay. How about Umairah? I'll just randomly pick up the names. Do you have any questions?
Doctor, can we have this slide?
Ah, that is a good question. Okay, you will be provided with the slides later on. I will ask the person in charge to share with all the students. Yeah. Okay. So other than that, do you have any other question? Chen Wen Chang, Dia Iklil. Do you have any question? Eva? No questions? All right. Do we want
Hello,
to do it,
teacher.
doctor? Yeah, sorry.
Yeah, I have one question.
Oh, great. Okay, come on.
So because my projects use my system use machine learning model, but I just design my system only use simple vision. Do you know what I'm saying? The simple vision, because I don't use the CNN model and another ways, because my data is so simple, and I don't have more data to train this to train this system. So I just use the simple version in Visual Studio Code. So I don't know it's necessary for me to use the CNN model, or just only use the simple version.
Dr. Shah, perhaps
Okay.
you have some idea.
Okay. Actually, you see, your discussion with your supervisor is very important from the beginning. Yeah. Okay. To choose the topic. Okay. Because as I mentioned from the beginning, when you decide to choose a certain topic, you will try to find the data first. Okay. So when you try to find the data, you find out there are not so many data, and the data that you find out is very small. As I mentioned just now, nowadays you can use data augmentation, yeah, to increase the size of the data itself. Okay. So that should be the not the we say main problem. And then about the algorithm, you said that you use simple algorithm. Okay. uh, it's not the matter of using simple or not simple, but it's a matter of the impact of your project. Yeah. What's the impact of your project to the community, to the society, or to the, I mean, to the industry problem? Okay. Some problem, like I mentioned, financial industries, they prefer to use just logistic regression, okay, to solve their problem of prediction or forecasting. Logistic regression is a simple machine learning algorithm, yet it is very powerful and it gives impact to the financial industry. So in your case, if you can highlight what's the impact of your project to industry or to any agency that will be helpful. Okay, because not only about the using simple solution, but you can look at the impact of the output. Okay, you are using
Okay,
you are
okay.
doing computer vision, right?
Yeah, yeah.
So what's the impact of your project? Computer vision for what?
Because I mean, I just use the various filtering conditions to train my system, and I'm not use I'm not use the for example the CNN model to train my my data. Do you know what I mean? Because I just use the various filtering conditions. For example, I just use maybe the marks is not more than 30 words, and use this condition to filtering my system data. So I'm not use another for example the CNN the machine learning to train my system data.
Uh, uh, what I suggest you, if you still have time lah, you can add data augmentation and also explainable AI to your system, because you're using, as you mentioned, you only use this simple machine learning model. So to add a value to your project, why not you use data augmentation and explainable AI? Okay, then you discuss on the impact of the output. Okay,
Okay,
impact
okay.
means how big is the, I mean, the output can help to solve industry problem, might be something like that. Yeah.
Okay, I know it.
Yeah. Okay.
Okay,
Thank you.
thank you.
All
Yes.
right, thank you for the question. So I can see another two questions in this Q&A chat box. So the first question is from Aisha Aina for Dr. Shah. For FYP scope, is it compulsory to refer to an industry domain expert? So that's the question, Doctor.
For final year project, it's not compulsory, but it will give you value added to your project. Okay, it's not compulsory, but will give you value added. Your project will be more interesting. Okay, because the problem that you are trying to solve is not problem from journal, but it's a real world application problem. Okay.
Okay, all right. So that should be answering the question. So the next one is from Lin Jingzi. ML or DL, machine learning or data depends on your objective, not specifically some kind of models. Or is it a question or it's a statement? I can't really understand. ML or DL depends on your objective, not specifically some kind of models. I think this is the question, but it sounds like a statement.
So it depends lah. I mean, whether it's undergraduate or is it master level. Okay. As I mentioned, you don't have to go for complex solution, but try to find the right data and the right algorithm to solve your problem. Okay, but you can add few, we say, few elements such as data augmentation or explainability, AI explainability into your algorithm. Yeah. Okay. It doesn't matter whether you use deep learning or conventional machine learning. It's not a big issue. Okay. And the most important part, I think, is the impact of what you have done, the impact of your project. Okay. So that one is what we say contribution to the community lah, yeah, or to the industry or the practice. Okay.
All right. So, okay, thank you, Doctor. So, any more question from the floor
I
from
want
the
to add,
student?
Dr. Faz.
Sure.
Let's say if you are using a single model, such as conventional machine learning, such as SVM or ANN, if you want to go for further, you say, further you want to explore more, you can try to use ensemble method. Yeah? Meaning that you combine a few models such as SVM, KNN, and random forest. You combine them to make an ensemble method to see whether ensemble method give better performance or not compared to single. So ensemble methods is actually a good, we say, a good way to explore more lah on machine learning if you are using only conventional machine learning. When I say conventional machine learning, it means that, let's say, for example, SVM, KNN, random forest, that one is conventional machine learning. Okay.
Right. Thank you, Doctor. So any more questions?
Soft voting, hard voting, or that one. There's so many things that you can explore actually to make your project more interesting.
Okay. So any more questions from the students? You may raise up your hand, you may write down on the chat box, or you may ask directly by switching on your mic. Anyone? Okay. So Dr. Shah, are we going to wait or we just going to close up the session?
We can close up the session.
Right. Okay. So I believe that everyone is really understand the topic. You have no questions, so perhaps you can just speed up your FYP submission in terms of the reporting. Okay. No, don't ask the same question to your supervisor because you have the platform and you did not ask. So we are believing that you really understand on it. All right. So once again, thank you very much, Dr. Shah, for this insightful sharing. So it should be very beneficial for the student in terms of choosing their best evaluation techniques for their FYP. So thank you once again to all the participation, which is from the students as well throughout this webinar session. So with that, we come to the end of today's session. And for the Muslim, let's close up our session today with Tasbih Kifarah in Suratul Al-Az. All right. So that's all from us. Thank you so much. Stay safe and have a great day ahead. Assalamualaikum and bye.
Okay, thank you.
Thank you, Dr. Shah.
Okay, welcome.
Thank you, Doctor.
Thank you, Doctor.